Hello, good afternoon. I apologize for starting this section very late. I was having network issues. Please, if you can hear me, kindly say that you can hear me. Tanya? Okay, I'll start by sharing my screen. Please be on the call. I will soon start sharing my screen. Sorry, I apologize for that delay. Network has been very crazy, trust me. So I'll just start sharing my screen so that I will not, stay here and network will continue to. So if you can see my screen, kindly indicate that you can see my screen. So I started by installing the libraries I will need. We've installed all of them, so we're going to wait for them to run. Daniel, can you hear me? Okay, moving forward, I will import the necessary libraries for today that I will need. So I'll import all of them. That has been successful. So also setting some options for a better format and visualization of data sets. Then I have to mount my Google Drive so that I can be able to access my file. Then I want to start by saying that I'm using about 3 data sets for this section. one of the data set is files.csv file. It contains data about worldwide food and feed production from 1961 to 2013. Then the second data set is food production, CSV. Food production. It contains data about quantities of natural resources exploitation and pollution levels that are produced in the various steps of the production chain of 43 of the most produced foods in the world. World population, we have another data set. The name is world population. It contains data about world population density by country from 1960 to 2017. So moving forward, I'm going to show you that I read the data set using read_CSV compandas and read_Excel compandas and all. So then after that, I checked the heading of the first 5 rows of my data. That's particular the third data set. So checking it, I can see what it has. So the next thing I would like to check the shape of my data. It has about 21,477 rows and 63 columns. So I'm checking the data types of my data. So when I scroll, I will see that I have the area abbreviation as object, area code, integer. Area, object, item code, integer. Then we have other ones as floats. Then there's this one that 2012 and 2013 that is integer. There is an integer, which is integer 2064. That's year 2012 and year 2013. So the next thing I'm going to do now, I'm going to I'm also going to further know the data types of my columns. This is like another function here. This is like another function to know your data, the data type of each columns of your data. So moving forward, I'm going to say, okay, since my 2012 and 2013 year is not in float and others are in float. So what I'm going to do, I will just convert them to float because they are in integers. So I'm going to convert them to float. So after that, I had to now check out my data set and see the columns. I'd like to see the columns. So if you run this too. Sorry, I think I did not run the previous one. Because it was kind of giving issues, so I had to restart. Yeah, so you can see that we have all our columns after converting the year 2012 and year 2013 to float, which was in integer format. So right now I'm trying to check the columns and see what I have in my data set. I have area abbreviation, I have area code, I have area, I have item, and I have item, element code, and the rest of them. Then I have several year columns from 1961 to 2013. So the next thing I'm going to renaming the columns into snare case and truncating the character Y from years columns. So at this point, I do not want all my name columns to be in alphabet. So I just want them to be in lower case, letter. So when I do that, when I run this particular function here, it's, this clean headers function, and it helps to convert all the uppercase to lowercase. So the format, and I'm saying that wherever there is Y, replace it with nothing. So when I now check the columns, I'll find out that all the alphabets have been turned to lowercase. And you can see that the Y character, they are all eliminated from the year. So this is it. Moving forward, I would like to, so I will just run this. Okay, I've run it before. So next thing I want to do is variables that store the number of rows before removing the duplicate. So I want to check duplicates, and I want to first of all check the total number of rows I have before I remove the duplicate. Then after removing it, I'll not check the remaining rows that are available after removing the duplicate. So what we're going to do is what I'm saying here, I'm checking the shape of each before and after. Then I'm not saying if before is equal to after, print no duplicate. It means that there was no duplicate. So before and after, they all have the same rows number. Then I'm saying, okay, if it's not so, if before is different from after, that's else. I'm not okay, before minus after. Duplicates were found and removed. That's if in case there were duplicates. So when you printed out, printed number of rows before dropping duplicates, which is 21,477. Number of rows after dropping duplicates, 51,477, which means that there are no duplicates, and it printed out this particular option here saying no duplicates were found. So this is how you check if your data set has duplicates. So, I think I've run this. So now I'm trying to, moving on to the next cell, you will see that here I'm trying to know the features of my data set. Like I would like to know most frequent data points and the most frequent and the less frequent data points for each column. Now we are trying to know the most frequent data points in the categorical columns, not in the numerical columns, okay? Because you can't just, because the numerical columns are plenty and they have lots of numbers, so you can't even identify which one is most frequent and which one is least frequent. So using the function I ran over here on count, std.count, exclude numbers. So that's saying that we don't want to involve our numerical columns. So at this point we have units. The count of unit column is 21,477. The unique number is 1. So this is the most frequent data point is 1,000 tons, and that's just one unique number. So the element has food and feed as a data point. For food is the most frequent, while feed is the least frequent. I don't know if you understand me, but I guess looking at this table here, you will be able to have understanding of what I'm saying. So moving forward, I noticed there's a mismatch between area and area abbreviation. These are supposed to be country names and country ISO code. respectively. So checking the unique values of the columns should return the exact same number. So printing a list of unique values of area abbreviation, and item columns sorted alphabetically. So I say 2O_check equals to printing out the list of my columns, and I say for column in 2_check, I want to print column /n sorted clean underscore FAO column dot unique. So I'm saying I want the unique numbers that's for all the column in 2check. I want the unique numbers. Okay, so I've already defined my 2check as area and area abbreviation and item. So I'm just looking for unique columns, the unique numbers in this columns. So if you print that out, you see, excuse me. So if you print that out, you see area, you see area abbreviation, you see items. So all these things I'm doing, I'm trying to conduct data analysis on my data set, on the first data set I'm using. So this is how you conduct data sets, correct spellings and correct so many errors. You know, when you have different abbreviation, like one abbreviation assigned to different years, and you know, that's crazy. You need to clean up your data. So that's what I am doing currently. So from here now, I actually noticed that that some of the countries have wrong spelling, like Taiwan, Macau, and Hong Kong. They have wrong spelling. So what I'm going to do, I will just use this function here to filter, and then I'm going to correct them. So when I run this now, so I'm going to so this function here is saying clean underscore FAO area. The column name we are focusing on this area. I'm saying area dot apply lambda function Taiwan if Taiwan in S else S. You understand? Like if Taiwan is in S, you should go ahead and filter it. If it's not, whatever that is in S should come out. That's what it's trying to say. So moving forward to the next cell, I'll now say, okay, clean FAO equals to clean underscore country. This is a function. So this is the name of our data set. I'm saying area, input format. I want the name and official output format. I want equals to name, visit distance equals to 2, in place equals to true, error raise. Sorry, error raise. So if I run this now, it will go and correct all those errors on the area column. So, and it will even create a new column that has corrected the names of the country. See where the new column is as area clean. So moving forward, I'm going to check if we have one particular abbreviation be assigned to more than one country. Okay, so this function explains how to check that. So this is a code underscore unique equals to data.group by area abbreviation, area clean dot unique. So I'm trying to know the area abbreviation that is being assigned to different countries, because definitely when you have a data set like this, such things are bound to happen. So you can see that this is the output gives us, it shows that this, you say that this code AZE is being assigned to 2 countries, CHN is being assigned to 3 countries, THA is being assigned to 2 countries. So how do we now want to identify, this next cell wants to identify which countries are being assigned to this particular code. So you will see that Azerbaijan, and Bahamas are actually assigned to this particular code, AZE. So CHN is being assigned to Hong Kong, Macau, China, Taiwan. So THA is being assigned to Thailand, Macedonia, and it's not supposed to be so. So we have to correct that. So this function here does the correction. Fixing the wrong abbreviation, the wrong area abbreviation value. So this is what this function is all about. So in this function, we are saying, I'm saying clean, that's our data set name, area clean, and I'm focusing on the column area clean. That's where we need to make correction. If area clean is equals to Bahamas, this is the spelling I want it to be. That is what this particular thing is trying to say. Yeah. So when you run this now, I think we have done it. Okay. I think I will run this. Sorry, I think I'm having error here. Area code, item code, element code, not found in the projects. May I just connect this up and see. Okay. That has run. Moving forward, we will say, okay, filtering to check if there are negative values. So when I filter this, I will realize that 2012 has negative value and 2013 has negative value. So I'll move to the next function that will help to eliminate. Okay, for instance, this particular function now is saying we want to check and investigate which country has a negative amount of production for which item and element. You understand? So we want to know which element and which country actually has the negative value. It's not just enough saying that negative value is in 2012 and 2013. So, when you are doing data analysis, you need to spend a lot of time in cleaning up your data set. It's very important. So when we run this, you see that area clean, item, element, food, and all that. These are the ones that have the negative value. So this next function is to drop the negative values, and we also want to check the missing values. Moving forward, this function here now is to check for missing values in the data set. So you find out that each row in this data set of mine has missing value. So I had to identify it. We have about 3,539 missing values. Then this is the total amount of every row. So you can imagine if you minus this from this, you get data points that do not have real data points values and not missing values. So this is the percentage of each rows of the data points that have non-values. About 16.48% of this column of the column data point has non-values. So I'm going to creating the data set. So I'm going to separate in my food production, this particular data set right now. I'm going to separate my years from my other, I'm going to create a year, a data frame that has only years. And this is what this function is all about. So I'm going to drop some null values. I'm going to replace the ones that could not drop. I'm going to replace them with 0. Since some of them are numerical, values, columns. So I'm going to further, filter and say, okay, anywhere there is a_df equals to 0 dot all as is equals to 1, that it should just, lastly, we can create a list of indexes on the rows of the year data frame that has only 0 values and all. So that's what this function is trying to do. So finally dropping those rules, so we now drop them and we have our year_df. We have two data set that has, only the year numerical values, and we also have clean file, clean FAO that has only both categorical columns and numerical columns. So look at it now. We have the year data set that has really So move on to the next data set analysis. We have about 3 data sets. So this is the second one. Okay. So this is to know the shape, which is 43 rows and 23 columns. This is to describe to know the count, the mean, the standard deviation, mean, the percentage, and the maximum number. So this is to know the columns. Then after that, I had to convert just like I did in the first data set, I had to convert some of the names of the column to lowercase. So the next thing, I dropped some columns. This is me dropping, this portion here is for dropping some of the columns. Then after that, I'm going to check the heading of each data set. Then the next thing I'm going to do is I'm going to drop some null values here. This portion is to drop some null values. This is why I'm trying to speed up because we have a long way to go, not necessarily visualization. I just wanted to expose you guys how to use 3 data sets to work, to answer some questions and to know patterns and all. So I don't know if I already showed you guys the topic. I'm sure you guys already know the topic. The topic is discovering patterns from using a data set from the data set. So this function actually is saying checking the negative values for the land change column as seen in DF.describe. DF.describe function. So we are checking for negative values and we are able to identify. So and when you identify them, we're able to filter them out. So the next thing for the population data analysis, this is for the third data set. The next thing, we converted the columns to a lowercase. So this is it, and we're trying to say here, dropping some countries that are not necessary, like we don't want Channel Island, Caribbean small states, Pacific Island small states, and all. So we don't want all these country names, and we just have to drop them, So this is the population DF. So moving to the visualization aspect, the goal here is to provide a list of top 10 food products that contribute the most to pollute our environment. Now, in our environment, so many food production actually contribute to environmental pollution, air pollution and all that. So we're going to know which food contributes most to contamination of our environment. So this is the visualization here that I did. So I'll urge you to go back after this section. Please come back and watch this video over again because I you need to understand it better and know how I was able to plot this particular graph. So I'm trying to know which food actually contributed that was more hazardous to the land use per kilogram per underscore meter per kilogram. This is a column in our data frame. So I'm trying to know which food contributed to its pollution. Okay, so when you scroll down, you will see that olive oil contributed more to land use compared to not actually is a second pollutant, why this is the first. So we'll check the next column because we have about 5 columns to check. So moving on to the next one, now we want to check for eutrophin emission per kilogram underscore G per kilogram and all. So this is the name of the columns are quite long. So this function means I just want the percent 75. I want above 75% of this particular column. I want to use it and plot, my graph. So that's what it's trying to say in this first code, this line of code here. So the next thing I'm saying, I'm going to sort my data sets. I'm going to this log function is a filter function. So I'm trying to filter only food products, this particular column, and I'm going to sort by this particular column, which is entropy. And I want it to be in ascending, sorry, I want ascending false. I want to be in descending format. So the same thing here is being here. And then this particular one, you're saying that I want 10 data points out of this particular column. I don't want to plot all of them. I just want 10 data points so that it can be easily read by if it's your board of directors that is giving this kind of assignments. It can be easily read by the stakeholders or anybody else reading it. So checking, you see that olive oil too contributes more to this particular entropy pollution. You get, so olive oil contributes more compared to nut and other food. So going down, you see that we have another entity again, which is freshwater withdrawals. Okay, what actually pollutes our water? Want to know which particular food product pollutes our water. So you see here, when you check it, it's kind of that cheese pollutes our water more compared to not pollute our water too, but it's not as much as cheese. And fishes too, they have a way of polluting the water and make it unbearable for humanity. So you see beef has a way of polluting the water. So you can see the first stop for food that pollute our water. You can even see rice, you can even see olive oil. Now look at olive oil does not pollute water, but in another particular entity actually pollutes that particular, maybe like land use cape. So moving on to the next column. So I'm checking which food corrupts our environment. So the next column is scarcity weighted water use. So we're going to know which particular food corrupts this scarcity weighted water use. You see that nuts corrupts our water. This other one, cheese, does that too. Olive oil, same thing, and lamb. Even beef too can be contribution to that. So to check, you can even see greenhouse gas emissions. So we are trying to know this particular cell is trying to explain. We want to know the top 10 food items for that contributes greenhouse gas emission. You see beef, you see lamb, you see cheese, you see beef again. So they all somehow, this lamb cell is also somehow beef too. So they are all from animals and they contribute to, polluting the environment. So moving on to the next. So this next cell is trying to explain, this chart here is trying to explain, like you can see the labels here, you can see farm, you can see land use change, you can see animal feed. So we're trying to know, put them in this format to know which particular food product contributes, which of the food product has the highest number of contribution to environment pollution. So you can see lamb has the highest. You can see beef. It's like beef is like the second highest. So I think after the lamb, you see dark chocolate. They contribute a lot to, pollution, comparing them to other food products. So moving on to the next, you will see that here we have coffee. Coffee has a way of contributing to the environment's pollution. So the next thing you see is this one, olive oil has its own contribution. So I created a data set out of already existing data set, and this is what it is here. And this is it here. And this is the function, this is the code used to create it. So after that, I have a plan of moving the data set to Power BI to further create a map kind of visualization, because I'm trying to leverage the fact that I have latitude, longitude, and with that I was able to create a continent, and I was able to get total production. So what I did was all those particular, I was able to get a total production. Then I was able to combine all the years together and put them in one column instead of them appearing in different columns. So this is the function that actually gave us this output. So moving forward, I saved it because I was going to call it in the Power BI. So I'm going to show you the visualization I built in Power BI. So now this is our next chart, where you see the trend, the pattern in food production increase across the country, across the years. So as the year, as the world is developing, the food production kept increasing as the year goes by. So you can see that feed kept on, it was kind of below, it is below food. I don't know why, maybe because animals use feed and humans use food. So this is it. So this shows the pattern of food production, the trend across the years. And this also shows the trend in feed production across the years. So the chart is self-explanatory. And this is the code that brought about that chart. So you can please go back and watch this video again. You can even possibly try it and try the functions and understand how it's done. So now we want to know yearly production by continent. We want to know which particular continent had the highest food production so far. So you can see Asia. Asia has quite a number of food production, more than Europe and America. Even Africa is the lowest in food production. So that's why they say Africans are hungry. I guess that's the reason. So now when you slide this is like a filter that helps you. This is like 1961 food production, right? So when you slide to 1963, the Asian food production increases and it still remains same. So Asia has been very consistent in their food production. So when you move this slide, you see that Asia is still the highest, 6 Europe is second best, and America followed by America. And I think if we move again. So let us fast forward it and move to PV20. So as you're going, you can see that Asia remains constant with their food production, and they kept increasing. They didn't stop producing food. They even got better. And same thing with Africa, Europe, and America. So they keep increasing in size. So till 2012, till 2013. So as of 2013, Asia, see the gap between Asia and America. So Asia kind of has the gap, the difference is too much. So it means as the technology was improving, they were improving in their food production. They got other means and other sources of producing their food and all. So and Africa too also increased. Oceania is the least. So moving forward. So this is also trying to explain top food element produced in 1961 and 2015. So you can see China. China has the purple color, India has the black color. So this is based on population. Obviously, China is the first most highly populated country, followed by India. So definitely they will always have food for their citizens. So, and this is the code that generated. This is the code that generated that graph. So it can be student variable. So that is it for now. So I'm going to open my PowerPoint so that I can show you the visualization I created. So I couldn't I had to use snacking to extract those visualization because I can't have my Power BI and Python running at the same time. It's going to really be slow. So that's why I used this PowerPoint to show you guys what you can do. You can also explore, like further analyze your data set. So this is what I was able to do. This is a map that shows food production across the continent. You can see Asia. Obviously, Asia has the circle of the Asia is quite big. It shows that Asia is the largest continent that produces food, followed by America. This is South America. See here, see the circle. Then these are other continents. You see the circle shows that it needs food production. Okay, this is like it's the same map, but I changed the color. So you can always play around your visualization. You can always play around it and make it more colorful and make it more interactive and appealing. So if this visualization was in Power BI, it would have been very interactive. You would have seen the figures, and right now it's very static because it's like 2D. So this is food production in all countries. So you can even see different countries with their different size of food production. So I guess this particular one is China. It is China, or is even Algeria. So if this is the level that has all the names of the countries and all. But obviously from our Python visualization, we know that China is one of the highest countries that produce food. See where the China on showed here. This is China, showing that they are the first country. They are the best country in food production, and they are the highest in food production. See China. After China, you see United States, then you see India, then followed by Brazil, Germany, and also, I don't even know if you can identify Nigeria here. So it means that these countries, they have lots of food. Like their citizens will never be hungry. You have lots of food whether it's packaged food, sachet food, they have lots of food in their country. So there is possibility that you will have so this is another visualization. This is a trend, year-to-year comparison. So the color identifies the year. So this is sum of food production in 2021, the sky blue. Then the royal blue is sum of food production in 2020. This one is the sum of food production in 2019, followed by purple, sum of food production in 2018. And this is another type of purple. So this is 2017. So that is it for now. I don't know if you have any question. Please send it to the chat. I will answer your question immediately. If you have any questions, please ask me. Do you have any questions? And please, if you actually understand what I have said so far, the visualization, or if you have any question regarding the code, how I did my EVE and all, how I was able to do my visualization in Power BI, please kindly send the chat here. I have 10 minutes to entertain questions.